2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You are looking at a live view of Falcon 9 awaiting liftoff at 7:25 a.m. Pacific Time from Space Launch Complex 4 East at Vandenberg Space Force Base in California. Today's mission is part of the National Security Space Launch, or NSSL program, managed by the U.S. Space Force's Space Systems Command. Today marks SpaceX's 12th launch for the NSSL program overall, and it's our first NSSL launch in 2 years from the West Coast, where our last NSSL mission was the NROL 85 mission in April of 2022. Hello, my name is Atticus Videra, and I'm a propulsion engineer here at SpaceX. We're super excited to be here with you today, bringing you coverage of our 37th launch just of this year. Today's USSF-62 payload is part of the Space-Based Environmental Monitoring, or SBEM, which works with civil and international partners to deliver environmental and tactical intelligence. Today's payload, known as Weather System Follow-on Microwave Space Vehicle 1, or WSF-M, will help provide monitoring of weather on Earth as well as in space. With the launch of today's mission, Space Systems Command continues its path to deliver the next generation of environmental monitoring capabilities. And with that, here's a video with a closer look at the payload.
Weather impacts every military plan and every operation in every domain, including space. Mission success and individual safety rely on access to comprehensive and accurate environmental data. New microwave imaging developed for the U.S. Space Force by Space Systems Command's Space Sensing Directorate closes critical gaps in space and terrestrial weather intelligence, capturing real-time data on space weather in low Earth orbit, wind speeds over ocean surfaces, tropical cyclone intensity, sea ice characterization, snow depth, and even soil moisture, monitoring the most remote areas of the Earth, helping to protect lives around the globe.
At T-minus 14 minutes, the payload is healthy, and all systems are go for an on-time liftoff this morning. Weather and the range are also green for today's T0. But for now, let's take a closer look at the rocket on your screen. Falcon 9 is a two-stage rocket and is the first and currently the only orbital-class rocket capable of reflight. The entire vehicle is just about 229 feet tall, which is about the height of a 23-story building. Since first taking flight in 2010, our Falcon 9 rocket has made 320 flights, and it's delivered all sorts of payloads to orbit. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin 1D engines. Today is the third flight of the booster that you see there on the pad. Underneath Falcon 9, you can see 9 Merlin engines that power the Falcon 9's first stage, which you see there on your screen. Named after the Millennium Falcon from Star Wars, the number 9 refers to these 9 engines. The second stage has a slightly modified engine on it called the Merlin Vacuum, or MVAC engine, and this engine has a larger diameter nozzle, which allows the second stage to be better adapted to perform in the vacuum of space. The large structure with the pointed nose that's on the top of the second stage is the payload fairing, and it's composed of 2 halves made of carbon composite material, and those come together to protect the payload until we are in the vacuum of space. At just about 17 feet in diameter, the fairing protects satellites on their way to orbit, and these are jettisoned approximately 3 minutes into flight. Now here's a look at today's payload being encapsulated in the fairing as the payload was being prepared for launch. The fairing halves supporting today's mission are in fact flight-proven, having last flown on USSF-62, and today both of these halves are flying for their second time. After separation from the second stage, Both of the fairing halves will return to Earth, and they will be recovered by our recovery vessel Go Beyond. So for now, let's turn it over to John and check in on the status of the vehicle.
T-minus 11 minutes and 30 seconds, the SpaceX team continues the countdown towards our 37th launch of the year. I'm John Innsbrucker, and I'm the Falcon Principal Integration Engineer at SpaceX, excited to be joining you today. Now, currently, the good news is all systems are go. At T-minus 38 minutes, the SpaceX launch director conducted the electronic poll of the launch team. We got the go for both prop loading and launch. Now, we're currently loading both RP-1 kerosene and liquid oxygen propellants onto the Falcon 9 first stage booster. And we've already completed loading of kerosene onto the second stage. We're now down to just loading liquid oxygen onto stage 2. Meanwhile, the TTEB ignition fluid that we use to light the Merlin engines, that's already on board. It's stored in small canisters that we installed while preparing the stages for launch. On top of the Falcon 9 is the spacecraft. Payload team reports they're ready for launch. So overall, we're tracking no issues on the rocket. Spacecraft's ready to go. And as you can see from the weather on the screen, we started with better than 90% chance of good weather, and we've remained good during the countdown. And of course, the range, they have declared they are ready to support a T0 of 7:25 a.m. Pacific Daylight Saving Time. Now, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. But everything's looking good right now. With that, let's head back to Atticus to learn more about today's mission.
If you're just joining us, today's mission is on behalf of Space Systems Command, or SSC, which is located just down the road from us here in El Segundo, California. Space Systems Command is the U.S. Space Force's field command responsible for acquiring, developing, and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space. SSC manages a $15 billion space acquisition budget for the Department of Defense and works in partnership with joint forces, industry, government agencies, academic and allied organizations to accelerate innovation and outpace emerging threats. For more on SSC, let's check out a short video on their mission.
The ultimate high ground has no ground. The satellites in orbit around our planet provide the critical infrastructure we use to defend and protect the security and prosperity of this world we all share. But space is no longer a benign environment. Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems Command, the time to act is now. The race is on.
Our adversary is out there. They are going to work every day, trying to work harder, smarter, faster than us. But we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering solutions to emerging threats, creating resilient space architectures we can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo, exploiting existing space architectures and capabilities in creative new ways, working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build, to deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments, to ensure that we can outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward. Speak up and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through any contingency crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level to make space work for us all. At Space Systems Command, space starts here.
At T-minus 5 minutes 50 seconds and counting, all systems are currently a go for an on-time liftoff. Now, while we were watching the video, a couple of important steps have been completed. We heard the spacecraft team declare they had gone on internal power. That happened just a couple of minutes ago. Also, we have just completed fueling of the Falcon 9 first stage. That gets all the kerosene on board. So we're still loading liquid oxygen on both the first and second stages. Now, the next event coming up is going to be the retract of the strongback away from the rocket. The strongback you can see on the right side of the Falcon 9, that's the structure that carries the air conditioning up to the spacecraft, the stages, the electrical signals, the pressurization gases, as well as the propellant up to the second stage, and of course that air conditioning into the payload fairing you can see at the very top of the stack. Now, in preparation for retraction, the clamp arms that you can see are on the very top of the second stage just below the payload fairing. They'll open up, they're hydraulically operated.
Tanks are pressurizing for strongback retract.
And you've heard that call out. We're pressurizing the tanks. We're putting a little bit of gas, kind of stiffens the tanks up, and that way the clamp arms open up with a nice rigid structure for the Falcon 9 underneath them. Now, once those arms are open, we then begin to recline the strongback away from the Falcon 9. That's a process. It'll take a moment. We've heard the call out. The process is now underway. And you can see the clamp arms around stage 2 are coming open. Coming up on T-minus 4 minutes, everything continues to be go. We're currently chilling in the Merlin engines. At T-minus 7 minutes, we open up the pre-valves, which allow the propellant down to the engines to get them prepared for the ignition just before T0. You can see the strongback is now retracting away. It's a slow process. We have hydraulic actuators at the base of the strongback that will pull it away. We do this slowly because you might be able to see we still have the lines that are carrying liquid oxygen to the second stage, as well as the electrical signals and the air conditioning up in the payload fairing. We need to make sure that all of those easily stretch out and all the mechanisms work so that we can get all the way back to the 77-degree position without tugging on any of the lines. Continuing to look good. You may notice a difference here at Vandenberg.
Launch load is complete.
T-minus 3 minutes. We've got the call out right on time. Liquid oxygen loading of the first stage is complete. We're now waiting for second stage. That'll finish up at just inside the T-minus 2 minute mark. I started to mention the strongback is different at Vandenberg. It's a different style. Cape Canaveral, for example, at Kennedy Space Center, we only recline a couple of degrees. Here we recline to 77 degrees and then pull away at liftoff. Now currently we're inside 2.5 minutes. The range continues to be green. And the weather, of course, as you can see there, has cooperated. Even the Vandenberg fog has stayed away. We don't expect any weather conditions to develop in the last couple of minutes. Again, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. We're listening in right now for LOX load closeout on the second stage.
Stage 2 LOX load is complete.
And the call out on countdown. Stage 2 LOX load is complete. All propellants are now on board the Falcon 9. We're now beginning to vent down the pressure that was in the tubing on the strongback. That's why you see the cloud coming there. The call out ground gas closeouts. That's where we bleed the pressure off. And that cold gas, when it reacts with the moist, humid air right off of the Pacific Ocean, gives you that nice white cloud, an indicator of launch coming up. Next event, T-minus 1 minute. We should hear the countdown that Falcon 9 flight computers are in startup and controlling the rocket for the remainder of the countdown.
Falcon 9 is in startup.
Right on time. Falcon 9 flight computers on stage 1, stage 2 are running the rocket through the last minute of the count. Listen to the go call outs.
LD is go for launch. Mission director is go for launch.
SpaceX Space Force directors are giving their go for launches. We're coming up on T-minus 30 seconds. All systems continue to remain go for launch of Falcon 9 and U.S. Space Force 62.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And a liftoff of Falcon 9. Go USSF-62. Go SpaceX. Equals pitching downrange. Stage 1 chamber pressure nominal.
T plus 40 seconds into flight, Falcon 9 on its way
Telemetry or nominal.
with U.S. Space Force 62. Good call outs there, power and telemetry nominal. Propulsion is nominal. We're into the throttle bucket. We're throttling down the 9 Merlin engines. We prepare for the period of maximum dynamic stress coming up in about 10 seconds.
9 is supersonic.
Faster than a speeding bullet, we've gone supersonic.
Max Q.
Max Q call out. We're through the period of maximum stress on the vehicle. We have throttled the Merlin engines back up to full power. Now coming up, we're going to have 4 events. We're going to get main engine cutoff. All 9 Merlins will shut off. We'll then get stage separation, where the first stage pushes itself away from the second stage. And then the second stage engine will start a few seconds later. The Merlin vacuum engine on stage 2 will ignite, and that'll boost the payload into low Earth orbit. We will then have same time, the boost back burn start. Falcon 9's first stage is going to ignite 3 engines, orient itself, and start to head back to land on land, right back at Vandenberg next to where it lifted off. Coming up on main engine cutoff.
Stage separation confirmed.
MVAC ignition. Stage 1 boost back startup.
You've seen it, the first stage heading away under the power of its 3 engines. The second stage vacuum engine is lit for second stage engine start 1. A nice view there of the Vandenberg coastline. Even a little bit of the white contrail visible from where we left Earth on Slick 4 East. Now the first stage boost back continuing. That'll go for another half a minute. We're coming up on fairing deployment next.
Fairing separation confirmed.
We've got call out that the fairing has successfully separated. You're looking right now a view. The first stage continues under the power of 3 Merlin engines. It'll continue to rise towards apogee before descending back down towards the landing zone at Vandenberg. Second stage, meanwhile, in the middle of its 6-minute burn on its way into the parking orbit.
Stage 1 boost back shutdown.
All right, we've had a successful boost back burn. We've shut down the 3 engines. The stage nitrogen thrusters now beginning to reorient the first stage, and the flight computer has commanded the large titanium grid fins to slowly begin deploying now that the boost back burn is over. So right now, we've had a great launch. First stage has done its job so far. It's on the way back. Second stage is running at full power. We're getting great views from space, and we're getting ready now for first stage to come back to landing zone. Atticus, why don't you take us through the sequence of events we've got coming up?
Thanks, John. You are watching a live webcast for USSF-62. We are delivering a payload that is part of Space-Based Environmental Monitoring, SBEM system, which works with civil and international partners to achieve their mission of delivering environmental and tactical intelligence to warfighters. Today, we will be attempting to recover the Falcon 9 back on land at Landing Zone 4, and in just a few minutes, the booster will execute an entry burn, and following that will be the landing burn. Both burns are meant to slow the booster down rapidly just before landing, and if we do have a successful landing today, that will mark the 279th landing of a Falcon 9 booster. And again, as I mentioned, in order to make its way back to land, Falcon 9 does have 2 more burns to execute. The next one coming up is the entry burn, where 3 of the Merlin engines will reignite. And this just helps to slow the stage down as it re-enters the upper parts of the Earth's atmosphere. And then the final burn for the first stage is the landing burn, and that's a single engine burn, which will bring the vehicle speed down very rapidly in order to softly touch down back on Earth. Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage. And during this portion of flight, Stage 1 is using nothing but the grid fins for steering as it returns to Earth. And these grid fins orient the rocket during re-entry, and they help to guide the rocket during its descent. Now, currently, we are seeing a view of the second stage, but occasionally you will see on the first stage nitrogen gas bursts for attitude control, which you can see there now on the left side of your screen. And these are basically used to position the vehicle as it heads back towards land.
Stage 1 entry burn startup.
And there's confirmation. We have just lit 3 of the Merlin 1D engines on the first stage. You can see now we are rapidly slowing the vehicle down as it enters the Earth's atmosphere. And this burn should last just around 20 seconds.
Stage 1 entry burn shutdown.
And there we go. There's confirmation of shutdown of the entry burn on the first stage. The Falcon 9 first stage is also equipped with 4 landing legs, and those are made out of state-of-the-art carbon fiber with an aluminum honeycomb. And they are placed symmetrically around the base of the rocket, and they will deploy just
Stage
prior.
1 FTS has saved.
Those legs will deploy just prior to landing. Speaking of landing, we are just about 60 seconds away from that. We are traveling over 2,000 kilometers per hour. This really puts into perspective the deceleration. In the span of just less than a minute, we will have reduced from twice the speed of a jet all the way down to 0.
Transonic.
You just heard that call out. Stage 1 is now traveling slower than the speed of sound as it heads towards land. We can see the California coast just below there on the left side of your screen, heading back towards landing zone 4.
Stage 1 landing burn.
There you go. Wow, great tracking shot of that landing burn. You can see that center E9 engine has now lit. We are slowing the vehicle down very rapidly. Should be seeing those landing legs deploy any second now.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And there you have it. We have successfully made the 279th landing of an orbital class rocket.
Stage 2 FTS has saved.
Coming up next, we will have the second stage engine cutoff, or SECO 1. And following that, we will enter into just about a 40-minute coast phase as the vehicle ascends to its target orbit. On your screen now is a live view of the MVAC engine continuing its burn.
MVAC shutdown.
And there we go, just had confirmation of MVAC shutdown. So with that, we are going to head into the coast phase. So we'll be back with you at just about the T plus 48 minute mark.
Nominal orbit insertion.
Welcome back to our live launch coverage of the U.S. Space Force 62 mission. We're just past T plus 48 minutes and 12 seconds. We're currently awaiting the relight of our second stage MVAC engine. That's coming up in just about 90 seconds from now. Now this burn, called SES-2, or Second Stage Engine Start 2, will last for just over 6 seconds. Now while we're waiting to come into coverage range of our African Indian Ocean ground stations, let's recap what we've had so far today. And it's been a successful mission so far. Falcon 9 successfully lifted off from Slick 4 East at 7:25 a.m., carrying the WSF microwave payload. Stage separation occurred just before 2.5 minutes into flight, right on time. That was followed by a successful landing of Falcon 9's first stage at landing zone 4, or what we call a land-on-land landing. At about T+8 minutes, we had successful second stage engine cutoff, and that was SECA 1. We had the go to orbit call out just as we were going off of the air for the coast period, and now we're coming up in just about half a minute on second stage engine start number 2, and then we'll wait to hear the GNC engineer confirm the orbit. On the bottom right, take a look at the meters that we've got. You can see when we left, we were at perigee. We've now gone halfway around the Earth. We're at apogee. We're going to light the engine, and you'll see the velocity increase to circularize the orbit.
And the ignition.
We've got ignition of the second stage engine. This is about a 6-second burn.
Nominal orbit.
All right, we've had the cutoff of the second stage engine, SECO 2, and the important part, the guidance nav and control officer has just confirmed that we have a good orbit. So this is the orbit that we need to be in for deploying the spacecraft. So we're now going to wait about a 5-minute period for deploy of the WSF-M satellite from Falcon 9's second stage. That's going to be just under 5 minutes from now, as I mentioned. We do this 5-minute wait because we want to make sure the second stage is quiet. We purge all the excess gases out of the engine. We monitor the engine. And then right before the spacecraft separates, we want to make sure we're not venting any liquid oxygen out of the tank. We want the second stage quiet and stable in what we call an idle state so that the spacecraft can separate without any disturbances. But we've got 5 minutes or so to wait, and so until then, let's toss it back to Atticus to learn more about today's mission.
Thank you, John. Space Systems Command is the U.S. Space Force's field command responsible for acquiring, developing, and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space. Space-Based Environmental Monitoring's SBEM mission is to deliver environmental and tactical intelligence to provide an operational advantage. SBEM space programs work in cooperation with both civil and international partners, and today's payload, known formally as WSF-M SV-1, or the Weather System Follow-On Microwave Space Vehicle 1, provides modernized space-based microwave imaging capabilities for low Earth orbit weather data collection. The WSF-M enables the production of enhanced weather prediction and analysis for global mission planning and operations. The satellite is a strategic solution tailored to address 3 high-priority Department of Defense space-based environmental monitoring gaps, and those are ocean surface vector winds, tropical cyclone intensity, and energetic charged particles in low Earth orbit. The satellite will also provide vital data on sea ice characterization, soil moisture, and snow depth. The WSF-M system is an important part of the U.S. Space Force's pivot towards a hybrid environment monitoring architecture. And this leverages existing weather capabilities, buys commercially available technologies and services, and builds inherently more resilient systems. WSF-M is the first of 2 satellites that BAE Systems will deliver, marking an important step in the U.S. Space Force's move towards this new architecture. WSF-M is now the United States' newest weather space system, and it will augment capabilities provided by the Legacy Defense Meteorological Satellite Program, or DMSP.
T plus 53 minutes, 17 seconds into the mission. All is going well. Spacecraft deployment coming up in 1 minute and 40 seconds. You know, Atticus, I was listening, you talked about DMSP, the Defense Meteorological Satellite Program. It takes me back to the launch. I was fortunate to fly a DMSP on a Titan II from Space Launch Complex 4 West back in 2003. So I'm glad to see that we're continuing on with that heritage, bringing new instruments into space to support the warfighter and the general U.S. population. I also note that today's landing at Landing Zone 4 is that former launch pad. We took the towers down, put some concrete in, and so we've got a nice big area where the first stage is sitting right now at Vandenberg. Now, as we come up, we're inside 1 minute to spacecraft deployment. We are getting coverage from both the SpaceX Indian Ocean Ground Station as well as the commercial African Ground Station at Hartebeestok. And we're getting these nice views. There's the view from the payload attach fitting camera looking forward. You can see part of the WSF-M satellite as we get ready to deploy it in about 16 seconds from now.
Payload deploy confirmed.
All right. Look at it go. Right on time, right into the orbit we needed to get it to. And so WSF-M on its way to begin gathering that data, turn into a useful product for the warfighter. Nice views looking at second stage camera. So Atticus, it's been a great day so far. In fact, all we've got left is the sign-off. So why don't you take it away from there?
Thank you, John. It is great to see that payload heading off into space. And we'd like to say thank you to the United States Space Force and Space Systems Command for entrusting us with today's mission. April is another very exciting month of launches here at SpaceX. So if you're interested in more launch coverage, be sure to check out spacex.com/launches. And of course, as always, thank you for joining us this morning, and we hope to see you again soon.